All right, so what we got here is that a student has a collection of baseball cards, and they've had it for several years. And B is the number of cards in the collection. So that's what B stands for. And the relationship that the student has with their baseball cards can be described in terms of time. So what we're going to do is we're going to take the fact that T is time and B is the total number of the cards that they have and explain what each of these equations would mean to the collection. So we're taking the equation and then putting it into words for the story. So we're kind of like half writing our own stories. So we'll do A together, and then I'm going to have you guys work together on B through D for a little bit. Because I want y'all to try it. Oop, that's not what I meant. Boop. So, looking at A, what do we notice about A? What can we do with A? How could I put this in terms of the number of cards they have in some number of years T? What does this mean in terms of this situation? What does B stand for again? The total number that they have. So you can just like start by taking the words we have. The total number of cards and we're going to do some kind of ucky grammar here for just a second. What's another word for equals? There's lots of choices here. What's any other word? Equivalent? Same as? Is? The same as? I'm good with that. You can also just use is. Is also works. Like if we say x equals 4 and x is 4. Same thing. You can use is. But I'm clear with is the same as. And then 200. I might write 200. There's not a different word I could do for 200. What can I say about this? Boom. And I'm going to put the plus as grows. So it's increasing. That's groans. There we go. Grows by 100 each year. So what we're doing, it kind of feels like a translation here. We're not really mathing. It's more like a translation. Math into English, and then we'll do English into math. So that is a perfectly acceptable answer. The total number of cards is the same as 200 and goes by 100 each year. It is not really a way we would talk, but it's a perfectly functional answer. A way that would be matching to kind of the way we talk would be something like, the student started with 200 cards and buys 100 more each year. That would also be a perfectly acceptable sentence. Oh, I love when I have mistakes in the ones that I write. Okay? So you're going to kind of come through and just like take each individual piece and bust it up, put it into words, and then see if you can make it something that would actually be something we would say out loud as a human. Because this kind of sounds like AI wrote something right here. Like that sounds like I said, put this equation into words into ChatGPT. Like, that does not sound like a human wrote it. It is something we wrote. But so see if we can write it in a way that a human would talk. So I want you to try B, C, and D. and you guys can work together. We're going to take like 10 minutes. I want you guys to try, maybe less. We'll see how you guys go. Try and put it into words, B, C, and D, and you can work together. Okay? But I want you to write it on those lines on page 19. See what you can do. Write them as sentences. Remember, grammar is a construct, so get it to a point that is understandable. Spelling and subject. Good? So I got a marker. Big thing over here. I got this. feel like those of us that did it did just fine. Those of us that didn't, ain't working anyway. So let's just go. All right, so let's look at B. How did you guys put this into words? Mm-hmm. Yep.
And then it goes by 200.
The total number of cards is 100 and grows by 200 each year. Absolutely lovely. Or they started with 100 cards and buy 200 a year. Also perfectly acceptable. How about C? It's a little different on C. Yeah.
I said the total amount of cards after subtracting 2,000 from 100 that is added each year.
Super close, super close. Because what is different with the subtraction? Are we adding 100 a year? We're losing 100 a year. So one way to word this would be, they have 2,000 cards. And what's one way to get rid of some cards? They take away, they sell, destroy, burn. Depends on what their opinion on the cards is. Or they could just lose. Maybe they're 12 and they carry their Pokemon collection around and they just drop 100 cards in a year. Sounds realistic. And lose 100 cards per year. They 2,000 cards. I love that grammar for me. Maybe they have. Not they 2,000 cards. They have. Yay. We love Englishing so much. Yes, I will use that as a verb. All right, and D is very, very similar. It just feels super awkward. Because they start with 100 cards, and they sell or lose or destroy 200 cards in a year. So, yeah, that's what they put. That's what they have. It just means they've lost all their cards within 6 months. So, D it's very similar. It just feels awkward because it feels like we're losing more cards than we have. It just means it takes them half a year. Okay? So, sometimes our words only kind of make sense. But this is more about using the context to try and put it into words. Okay? Because what we're going to do on the next page, oh snap, we're not done. So the next page, page 18. Let's see if I updated the page number. Yay, it does have the right page number on it. Haha. Oh my gosh, these pages are slick. What we're going to do is we're going to look, yes or no, to does this equation match? Does this equation, 2x plus 5, fit the situation? So we have 6 situations here. And I want to know which of these could use the equation y equals 2x plus 5. So when you're doing something like this, you can just go through and try and spot it. Option number 2 would be to try and write an equation for each of these situations. Okay, so I want you to look through it for like a minute. Look through these. See if there's any that you spot right off the bat that yes, it will work or no, it won't work. I'm just going to write this bigger. All right. So what do we see? Are there any up here that you instantly know this is not gonna fly?
Oh,
Are there any up here that
D.
D? We think D, like you think D does not work?
Yeah.
Why would D not work?
I don't know.
Okay. So we're gonna go with guess on no. We'll talk about it. I have a gigantic smudge. My glass is right where that box was. I'm like, why is it all blurry? It's not. Just a smudge. Okay, so we're guessing no on D. Any other instincts we have on some of these? E is no? Why is E no?
So you think like, so it says 5 per deal.
Mm-hmm.
So that would be like 5
So that would be like a 5X. I'm with you. 100% I agree. Because there's a $2 fee and it's $5 per rental. So this would be 5X plus 2, which is close, but it is not 2X plus 5. I'm with you. Okay. Why did it jump back to the first page? Love that for us. So much fun. So then let's go through some of these others and see what we find out. Because we're not just going to go with... All right. So let's look at A. We've got 5 rabbits on the farm. So I got 5 bunnies. I'm going to write my 5 bunnies down. Yay! And each month, the number of rabbits is 2 times the number of the month before. Super awkward wording. So if month 1 we have 5 rabbits, how many rabbits do we have on the next month? 10. How many rabbits do we have on the month after that? I was going to say it's double, so it's 20. So what happens on month 4? 40. Is this going to be 2x plus 5 to get 5, 10, 20, 40? No. So when in doubt, pick some values and try it. Does anyone remember what this kind of function is called? When it grows like that? Huh? Not quadratic. It's not linear. Starts with an E. Starts with an E. Exponential. This would be 5 to the x. Okay, so it would be an exponential situation. So it's definitely not 2x plus 5. That is an eraser. That is not what I meant. I meant a laser pointer. Definitely not 2x plus 5. So when in doubt, test out a couple values. See if it fits. All right, so then we got Joaquin here earning $2 for each magazine sale. And every time he sells a magazine, they're also giving him a $5 tip.
That's a no.
That's a no. Why?
Because it would be 2x plus 5.
It would be 5x and 2x. So really, he's getting $7 for every magazine. So that one absolutely does not fit. How about C? We've got Sandy charging $2 an hour for babysitting. She is severely undercharging. I feel like they wrote that equation about 30 years ago. Because even I charged more than that when I was your guys' age. $2 an hour is nothing, unless she's 10. So she's got $2 an hour for babysitting, and parents are charged a $5 flat fee if they arrive home late. So if the parents come home late, how much money should she make? Yeah. Because the $5 is a flat fee, and it's $2 per hour. So it's 2x plus 5. So yes, that one actually does fit. Okay. So it looks a little weird, but it's the same thing. So let's go look at our guess of D. We have a sequence of integers. What are integers? Yeah, they're numbers. Do they have decimals? No. They're like the counting numbers. 1, 2, 3, 4, 5. That kind of numbers. Counting numbers. So I have a sequence of integers. The first term is 7. And the difference between any consecutive term is always 2. So it's counting by 2s. So 7, and then if I count by 2s, what do we get next?
8, 9.
9. What do we get next? 11. What do we get next? 13. Does this fit this pattern if it starts at 1? If it's dealing with integers, if x is 1, 2 times 1 plus 5, 7. If x is 2, 2 times 2, 4 plus 5, which gives us that 9. So this is the weirdest one for sure, but it actually does fit if we're living in the land of integers. Okay? But that's like super weird to think about. Because it feels like it's just like jump, 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 jump. So we've already talked about E. Let's look at F. Bless you. Andy is saving money for a new CD player. He began saving with a $5 gift, and he saves $2 each week. He is not in any rush to buy this CD player. Does this one fit? Yeah, this one does. Because again, it's $2 each week, $2 per week, and a flat rate of 5. That 5 is not changing at all. So the things that change are what get the variable. Okay? We have one more piece for today, which is the very bottom one. It doesn't look like it's going to take a ton of time, but the graph on the next page is also for it. So we're going to have to open sideways. Because what we have here is we've got a checking account. It's set up with an initial balance of $4,800. And $400 is removed from the account each month for rent. We are going to write an equation. We are going to make a plot. And we are going to figure out an equation for it to reach 2,000. So you guys have a whole sheet of graph paper. You do not have to use the whole sheet of graph paper on the next page. But you have a giant selection. Mostly because last year we had a blank page. And I had to do it on a teeny tiny Post-it. And it was very, very small. So I give you guys a whole sheet of graph paper over here. So I want you to try. See what we can do. First thing you need to do is figure out how to draw a graph. Do I need to have the whole graph like this when we're dealing with money and time? No. Because it's only going to be positive values. So you do not need to take up the whole page with the whole coordinate grid when we're not going to be working in negatives. Because we have time, which is going to be our months. And we definitely cannot have negative months. Negative months is time travel, and that's not a thing. Also, we're dealing with our bank account, and we are going to be good fiscal citizens, and we are not going to have negative bank accounts. That is a general good goal for life. Do not let your bank account go negative. It costs extra money to have your bank account go negative. No joke. They charge you a fee if your bank account goes negative. It's so bad. I have fallen down that hole once. Far. Like I wound up like $700. Yeah. In fees from being overdrawn. So yeah, don't let the bank account go negative. It adds up real fast because it's like $30 a day when your bank account's negative. Like every day they make it $30 harder to get out of that. Just saying, we all get there once, but try really hard not to. So we've got our money on our y-axis and our months on our x-axis. So figure out what you need to count by. You guys can each count by something different. That's totally fine. But I want you to try and get yourself a graph. Oh, actually, we have 12 minutes. We're going to work it together. Never mind. So our months, we're asked to get months up to 12. So we don't need to go super far. So I'm just going to count by ones. Well, did I give myself a graph? I did not. I'm freehanding this sucker. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because the rest go up to 11. How high do I need to go on this axis? Should I count by ones here as well? No. I would need a significantly bigger piece of paper. But I also don't necessarily need to count by thousands. Because if I count by thousands, I'm only going to be like here with my 5. So you can count by whatever you want. You have a nice big piece of paper here. Something that might work well, I haven't counted to make sure this fits, but it should, is maybe since we're going to be changing by 400, maybe we count by 400s. That would make our lives easier when we're plotting stuff. Not saying it's a requirement, but if it fits, I would recommend counting by our slope. So I'm going to count by 400. So I'm going to do 400, and then we're going to have 800, and 1200, and 1600, and 2000, 2000. I just heard somebody's brain break with that one. All right, count the whole way up. 24, 28. Mine are going to start getting real close together because I am running out of space. Luckily, y'all have an actual grid, not this freehand nonsense. 32, 36. Oh, I got to do more coloring. 40, 4, 8, 52, blah, blah, blah. On and on and on. And you don't have to necessarily label every single number up the graph. I did simply because I don't actually have a proper graph. You can do like skip counting and mark, 400, 1200, 2000, count up 5 and go to 4,000. Like you can label however you want to. Just make sure whatever amount we're going up for each block counts as the same number of dollars. So whenever we're drawing our own graph, you got to make sure you keep your scale consistent. And that is true forever and ever and ever in math. You always, always, always have to count consistently up the graph.
Is the top one 49?
I've got 48 and then 52. I just like running out of space. But I know our top value needs to be up there around 4,800. So when we're looking at this, you can either start with writing your equation or you can start with drawing your picture. Because where are we going to start with this situation? Where's my first dot going to be? Now 400. What is it?
Is it
0,
0
2000. Nope.
For the 1
Nope. So read through number, like the top of number 3 again. Don't look at A. Checking account is set up with an initial balance of 4,800 and 400 is removed from the account each month for rent. Where are we starting? 4,800. Our initial amount. And then how do I move? How do I get to my next point? Go down. How much?
2,000?
Not 2,000. How much is it changing each month?
400?
It's changing 400 each month. So if I go down $400 each month, so on month 1, the amount in my account is $4,400. For month 2, we're down to 4,000. Month 3, we're down at 3,600. So we're on our picture, if you counted the same as me, it's going to look like we're going down 1, right 1. Down 1, right 1. But it's only because we're skip counting. We skip counted here by 400ths. So it's going to look something like this. And mine is going to look like trash because everything is hand drawn. So it's going to look something like that. So this is just the story part, like this part up here. Actually no, it's B. We did B first. This is what our picture is. So even when we have questions that are A and B, doesn't mean we need to do A first. Sometimes B makes our life easier. Because what A is it's looking for a solution. They want to know what the solution is for what number of months M it takes the account to reach 2,000. So if we were looking at our picture here, how could I read that off my picture? How can I figure out how many months until my balance equals 2,000?
You will go to the 2,000 on the y-intercept and then go down to the months.
So we'd start at our 2,000 and we'd come over to our line and figure out where that is. And then we'd bring it down and figure out where that hits on our months. Those of you that have actual proper graphs, where does it hit? Seven. Right around 7. How could we do that with an equation? Gorgeous. Perfection. So what we can do, our kind of basic equation, the line we wound up graphing was the equation that our y equals 4,800, where we started, minus 400 m each time. So the equation for how we found this solution is 2,000. That was our y value. Equals our 4,800, where we started, minus 400 each month. So we kind of took our data, made our graph, and wrote our equation in a very strange order, but it's one of those times, sometimes it helps us see the patterns in it better. And for our equations, I genuinely do not care if you do it in this order or if you put minus 400 m plus 4,800. That's a little bit more slope-intercept form, and sometimes we feel significantly more comfortable that way, and that's fine too. As long as we have that it is falling, that's not the laser pointer, that it's falling by 400. Falling by 400. Okay? So today is all about our words, English into math and math into English. And so what we have now is like 8 minutes to look at homework 3. We'll have more time. I know, I'm horrible. To be fair, I'm pretty sure this chapter only has 3 homeworks. It might have 4. Maybe. So that means next week there is 0 to 1 homeworks. Okay, so I know we had 3 this week. But that means next week there's either 0 or 1. So if we need to wait till next week to do it emotionally, that's okay. Due dates in this class are a suggestion on everything except for tests and projects. Okay, the due dates are just so that we have a not giant block of them on the last day of the chapter. Okay, it is page 20. It's 100% the exact same questions. I just want you to type it in on Canvas because it's way easier for me to grade, and I don't want you to rip stuff out of the book. Okay? So, it is the exact same questions as on page 20. And I'm just going to tell you, the hardest one is number 1 on page 20, the pizza question. Okay? That one winds up getting a little confusing sometimes. So, maybe save the pizza question for last.